So hello everyone, hope you're doing and welcome back to my channel. Today we are at day 25 of the Made Leetcode challenge and we have a medium level question in front of us. It's question AC 7, new time, new 21 game. Okay. So for the last few days, we were having questions on heap and priority queue, but finally we are back to DP and this is a question on DP. Okay. It's a very tricky question. It's very, based on the words given, it's difficult to understand what is expected of this question. But if you try to understand if you just see the test cases, only then you will get to know what they are trying to ask. Okay, if you see the examples and the test cases. Okay, so based on that, we have come to a conclusion. We are doing the solution. Okay, I will definitely not say it's a easy question, but uh, yeah, we have to take this and see. For every question, we have to try to grab something. We have to try to learn something. Okay, we cannot say the question is not good or it's not understandable. So whatever be the question, try to at least learn something new. That is what we need to ensure for ourselves. Okay. So coming to this question, so there is something new game, 21 game they are calling it. Okay. So what is happening? There are one character Alice. Okay. So what Alice is doing is she is starting with 0 points. Okay. She it's a game and she is going to have some points. Okay. So initially she will be having 0 points. Okay. What we need to do is see she will be getting see she will be doing some moves based on that she will be getting some more points. Okay, so she need to play this game till she have crossed k points. Okay, so Alice stops drawing numbers when she gets k or more points. Okay, so she will do something, but she will get do something and get some points. She need to stop at a point, and that point is when she has k or more points. Okay, and yeah, that is the basic idea of this question. So what is that something is that she will be drawing up some numbers. Okay, so Alice starts with 0 points and draws numbers while she has less than k points. Okay, during each draw she gains an integer number of points randomly from this thing. Okay, yeah, where so what is the idea here is see, suppose I am at k. Okay, so what I can do is from sorry, not k, let us say at I am at index m. Okay, from m I can what I can move is I at least I can move to m plus 1 or I can move to m plus max points. Okay, anything between them. Okay, these are the ones. Okay, so where max was is the integer. Okay, so each draw is independent and the outcomes have equal opportunities. So please try to understand this question first. Okay, we have not come to end till now. First, let us try to understand what is k and what is max points. Okay, see, one thing is very clear. She is going to draw some cards. Okay, she will be getting some points out of that. But one thing is very clear. She will be stopping once she gets k or more points. Once she reaches k or more points, she will be stopping. Definitely, that's going to happen. Okay, and what are the points she is going to get? See, she is going to get points between 1 to max points. Okay, this is the thing. Okay, during each draw she gains a point. So just think it like this. Okay, it's like a number game. Okay, you are at 1, if you get 2 you will go to 3. Okay, if you are at 1 and you get 2 you will go to 1 plus 2, which is 3. If you are at 3 you will get 5, you will go to 3 plus 5, which is 8. Okay, it is something like that. Okay, so how much points you can get is decided by this factor. Okay, for example, I am at 7. From 7 to what max I can go is decided by this factor. Okay, so I can go from 7 to 8, which is plus 1, or I can go to 7 to 17, which is plus 10. Okay, so this factor is decided by this particular variable. Okay, remember one thing, once I reach k I need to stop. This is the point. Okay, for example, if k is equal to 8, so till I reach 8 I can keep on picking points and I can keep on going. Okay, that is the basic idea. But once I reach k I need to stop. And finally the now comes the this particular variable. Okay, what is the idea is return the probability that Alice has n or fewer points. Just see, this line is not at all clearly understandable. It's let me tell you, it's not logically correct statement. The statement should be something like this. Okay, we need to find probability that Alice has n or fewer points at the end of the game. Okay, one thing is very clear here. See, n or fewer points at the end of the game. See, this particular thing is missing in the statement given here. Okay, so what is the idea is now you'll be able to understand that. See, she will definitely stop when she get k or more points. Okay, so we need to find the probability that she has k points. So this is the basic idea. Okay, from k till n. Okay, what are the various numbers coming in between? We have to find probabilities of reaching them. Please make this point very very clear. See, she will be stopping after k. Okay, at or after k. Okay, but they have given n. So let me show you this. N is going to be greater than n. Okay, please have this thing very clearly in your mind. N is going to be greater than n. Okay, so we have to find the sum here. Okay, see here the sum. What is dp? I will come to that later. Just try to understand what I'm saying first. We need to find the sum till. So we need to find the sum of probabilities of reaching k to n. Okay, so k to n, there are some stages, right? Suppose k is 5 and n is 10, so 5, 6, 7, 8, 9, 10. Okay, there are 6 stages here. We need to find the sum of the probabilities of reaching these stages. Okay, we need to find the sum of the probabilities of reaching stages from k to n. Okay, that is the basic idea here. So now let so before doing anything, I will just define what is my DP. Okay, DP of I is, see, this is the time programming approach. Okay, DP of I is the probability of having exactly I points at some point in the game. Okay, at some point in the game. Okay, but one thing I want to show you before we begin. Okay, so this is my DP array. Okay, these are the various stages which we are going to get. Okay, initially I will be having 0 points. Then at some stage I will be getting 1 point. So I may or may not be getting, right. So these are the various stages. Okay, because we know very, see, we are the our focus of concern here is till n minus 1. Okay, once n to n minus 1, right. That is the basic idea. So these are the various stages which we can get. Okay, so for example, suppose I want to find how to, for example, the as I told you, what is my DPFI? DPFI is the probability, okay, of having exactly I points at some moment. Okay, so this refers to probability. Okay, now suppose I am trying to find the probability of reaching this particular blue box which is here. Okay, I am calling it I. Okay, so what are the what are the boxes which are going to contribute to it? Okay, for example, let us say my max points equal to 4. Okay, my max points equal to 4 in this case. That means the last 4 box, that means the last 4 indices or whichever positions or points, whatever you call it, only they are going to contribute. What is the basic idea? Let me show you this. Okay, the idea here is, see, to reach, yeah, sorry, yeah, to reach this blue box, only the last 4 boxes are going to contribute. What that means, suppose I am at 1. Okay, I'm at 1. I can jump from here to here. Okay, to this blue box. Similarly, from 2 I can jump to the blue box. From 3 I can jump to the blue box. From this 4 I can jump to the blue box. Okay, so what is the probability? For example, see, suppose the probability of reaching this one is dp of 1. Okay, suppose it is reaching dp of 1. So my max points is going to be 4. Okay, so from here, this particular one, I can have 4 possibilities. Either I can go to 2, I can go to 3, I can go to 4, or I can go to 5. Because see, from 1 I can do a max of 4 jumps. Okay, 4 points at max I can jump from, because max points is equal to 4. Okay, so that means from 1, I can either jump +1, or I can jump +2, or I can jump +3, or I can jump +4. So what are the possibilities? It's going to be 1 by 4 in each approach. Okay, so that's what I'm saying. So suppose the probability of reaching the 1 is dp of 1. Okay, so what I will do is dp of 1 into the probability of reaching the blue box, that is dp of 1 divided by 4. Okay, that is the idea of reaching blue box. So the one thing which I'm going to convey in this image is that when the max points is equal to 4, only the last 4, for example, for this blue box which is I, only the last 4 boxes are going to contribute. Because see, this box cannot from this box I cannot jump directly to this point. Okay, I will be joining it through some other box in between. Okay, that is the basic idea. Please have this thing in mind. Okay, now coming to the next image, the same thing here. So for this, the last 4 boxes of it are going to contribute. But remember one thing, as I told you, in the question is very clearly given, we are going to play this game till we reach the box K. Okay, once I reach K, I will not be taking out the further points. Okay, so once I reach K, this box I cannot, like, see, it's very clearly mentioned here. Once I reach K, I will stop drawing the numbers. Okay, I will stop drawing the numbers. That means if you see the next case, once I reach K, I cannot draw a pointer. That means from here I cannot jump to this box. Okay, from this place I cannot come here. Okay, so this is not going to contribute to my case. Okay, so only the last, these yellow boxes are going to contribute for this case. Okay, because see, once I reach K, I am stopping the game, right? I cannot do this case. See, we are trying to consider here, from here you can jump to this. Okay, from here you can jump to this, but once you reach K, you cannot make a jump. That is the basic idea. Okay, so while calculating probabilities, we need to consider only these things. Okay, and similarly the last case, once you reach K, you cannot contribute. Okay, that is the basic idea. So now coming to the code, this code is going to be a very simple thing. Okay, remember what basically is going to answer is this. Okay, yeah. At the end of the game, what is the probability that Alice has n or fewer points? Okay, so we need to start from K till n. Okay, we need to start from K till n, because see, she will stop the game only when she has K points. Right? Based on this statement, when the game ends, she is definitely going to have K or more points. Okay, there will never be a case when she has less than K points. So they are saying at the end of the game, what's the probability that she has n or fewer points? That means we need to find the probabilities, that sum of the probabilities that she reach k or more points. Okay, that is the basic idea. Let us say how we are going to implement it. Just remember this definition very clearly. dp of I is actually the probability of having exactly I points at some stage. Okay, so I'm going to define this. Initially all probabilities will be 0. It will have n probabilities. Okay, that's why I'm giving here n plus 1, because from 0 to n I want. Okay, so dp of 0 will be 1. Why? Because obviously we are at 0 means at the beginning ls has 0 points, right? At the beginning ls will have 0 points, so thus dp of 0 equal to 1. Okay, x is going to be the factor. For example, see, which you are seeing here, right? These yellow points, these yellow ones. Okay, I'm going to sum their dp of I values, and I'm going to show it in s. Okay, so what is s? S is going to be the dp of I values of those indices which are going to contribute. Okay, that's why I'm going to call it as s. Okay, so initially s will be 1 if k is greater than 0, otherwise it will be 0. Okay, see, when k is 0, that means we cannot begin the game basically. Okay, that means there's no need to draw a point. See, k is where, see, we once we reach k or more points, we stop, right? If k is 0, then why should we begin the game itself, right? That's why s will be 0 in normal cases when k is greater than 0, otherwise it will be 0. Now we're going to start. See, dp of I is dp of 0 is fixed, right? dp of 0 is 1. That means we're starting from dp of 1 till n. Okay, that is what we are going to do. See, dp of I, as I told you very clearly, s represents the factors which are going to contribute. So just try to understand here. See, as I told you, when I am at 1, I have, suppose maximum is 4. Okay, so it has 4 possibilities. Either it can go to 2, or it can go to 3, or it can go to 4, or it can go to 5. Okay, so there are 2 possibilities. For it to jump from 1 to this blue box, the probability is going to be 1 divided by max points. 1 divided by max points. Similarly for this case too. So to reach this point, the probability is going to be 1 divided by max points. Okay, but if you are see, this is some maths involved here. See, when I am saying, when I am at 2, for it to reach blue point, I have to do 1 divided by max points. Okay, but how to reach 2? For reaching 2, the probability is going to be dp of 2, right? So dp of 2 divided by max points. Similarly, dp of 1 divided by max points. Similarly, dp of 3 divided by max points. Like this, if you see the thing, I am dividing everything by max points. And if you see the dp of 1 divided by max point, dp of 2 divided by max point, dp of 3 divided by max points. See, if you add all these things commonly, divided by max points is common, and we are summing the dp values here. That's what is represented by s here. Okay, you see there was represented by x here. Initially it will be 1, but you will see in the case how it was. Okay, divided by max points. Now we will change as for the next steps. Okay, what we are doing, that is, see, adding the current I, adding the dp value of the current I. That is the one thing which we are doing. Remember, this will be done till I is greater than k, as I showed you here. Okay, in this case, k will, once we reach k, it cannot contribute, right? It cannot contribute. Okay, so that is what we are doing here. Till I is less than k, only then add dpy value. See, as represents those dpy values which are contributing. Once I reach k, I cannot contribute. Okay, that's what is happening here. I am adding dpy values. See, this is for the current iteration. These are preparing it for the next iteration. Please make this one very clear. This is for the current iteration, and these are for making it, like, preparing it for the next iteration. Okay, so once I is less than k, it will contribute somewhere. Okay, that's why I'm adding it to my s. Okay, now remember one thing, only these paths are going to contribute. That means if I am at 0, I cannot come to this. That's why the last thing which is going to contribute from this is I minus max points. Okay, so I, for example, see, 0 cannot contribute, right? So you will definitely understand I have to remove this 0. Okay, somehow. Okay, so what I'm doing is, that's, see, this part is for adding and this part is for removing them. Okay, what we have added already. Okay, so what we're doing is, if my I of minus max points is greater than 0, that means there are some things involved here which are not contributing, but they are present in S. Okay, I need to remove them. This is how I am removing them. Okay, this particular index. Okay, this has to be removed. Okay, because, see, it's not going to contribute. Okay, that is the basic idea. I minus max points. So if it is greater than 0, that means it's added to it, but it's not contributing to it. So I need to remove it. Okay, this is how I am removing it. I S minus dp of I minus max points. Okay, remember one thing, if it is less than k, only then it is going to be added. That's why I will be subtracting this only when it is less than k. Again, this thing, if it is less than k, only then I will subtract. Similarly, if it's less than k, only then I will add. If I'm adding, then I need to subtract. If I have not added, I should not subtract. That is the basic idea. Okay, that's what is happening here. Okay, see, k, after k, it's not added. That's why it should not subtract also. Okay, that's why this condition is needed. Please make these points very clear. And finally, this is happening. Okay, and ultimately when this loop is done, okay, when this loop is done, as I told you, I will be returning the sum. See, it's because, see, what is asked of the question, we need to find the probability that ls has n not fewer points at end of the game. Okay, so See, at the end of the game, definitely she will have k points. Okay, so the answer is going to be written k to n. Okay, so there is a sum of k to n. That is what we are doing here. Okay, sum from kth index to the last index. Okay. So yeah, friends, if you see what other doubts you can have is why we are taking less than k, because once we reach k, we cannot contribute. Okay. Similarly, why we are having this thing. Okay. See, the idea here is because see, once you reach k is not added. Okay. Once you reach k, you cannot contribute. So if I'm not adding something, see, if I'm not here is the adding part. Right? If I'm not adding something, I should not subtract that as well. Okay. That's what I'm ensuring through this. Okay. And what is this part? See, for example, when I'm in a list stage, this index is contributing. Okay. So I should not subtract it. That's why I'm just checking if I my max points greater than 0, only then I will be subtracting it. So yeah, that was all for today. If you have an end of, please do comment below. If you have a better about, please do comment below as well. This was a bit tricky question, but see, I've tried my maximum to explain you all the cases here. Okay, I might have gone a bit faster, but please pause the video, play it slowly, rewind and check. Okay, you will definitely be able to understand it. Yeah. If you have understood, please do comment below. But just remember one thing: S represents the factors which are going to contribute. Okay, they are deep. S because it's basically they are DP5 values, and finally we'll be subtracting with. See, it's maths. Okay, it's totally maths. I finally will be subtracting with the probability, which is max points. Okay, that becomes a probability. If you calculate mathematically, it will come exactly like that. Okay. So yeah, that was all for today. See you tomorrow. Thanks a lot.